Hey, what's up, YouTube? Greg here from GregsTutoringNYC. All right, so we're doing the 2024 SHSAT review cover to cover. That's the one that looks like this. Okay, so we have for 2024 admissions down there at the bottom. All right, so give me 1 second to bring this to the right section. So what we're going to do is the box plots for Form A, and then I'm going to do a second video with the box plots for Form B. Okay, so let me get set up here a little bit. All right, so I believe I wrote this down here. The first question for the box plots is going to be 72. This is in Form A. All right, so what we're going to do is rip this apart slightly first, and then actually try to go answer the questions. So we don't have a premise to work from. We kind of don't know what we're doing here. All right, so this is called a box plot or a box and whiskers plot. Okay, the basic premise is that this here is the box, okay, and then this thing here, whoops, my cursor's freaking out. This here and this here is the whiskers, okay? So these have names. This is the minimum of the data. So the 7 would be min, and the max of the data, this set of data, would be 12. Okay, give me 1 second. My machine is going at a snail's pace. So let me end something here. So I have something running in the background. All right, so that's the max. Okay, so for argument's sake, if this is turning out to represent a bunch of ages, okay, so the set of data, we make it a set, the lowest number is going to be 7, there's going to be something here, and the highest number is going to be 12. Okay, now if you guys know about your points of center, your central tendency, points of centrality, many of you also know about things like the range. Okay, so range is normally your max minus your min. Okay, in this particular set of data, we're going to have 12 minus 7 is equal to 5. Okay, so we're going to going through all the different aspects of the box and whisker plot, and then we're going to answer the question. So the question may not need what I'm talking about right now. I'm just trying to give an overview of what it is. Okay, this center line here, the 9 is the median. Okay, and then we have two other numbers here, the 8. This is normally called Q1, and Q stands for quartile, and this would be Q3. So we have the first quartile and the third quartile. Okay, the other names I just give, the min, the median, and the max, they're also quartiles. Okay, so technically the min is Q0, then we have Q1, the median technically is Q2, then we have Q3, and the max is Q4. Okay, so this is a different way to look at data. Normally we're looking at like the average, which is taking all the numbers into consideration and then dividing by stuff. And here, what we're trying to do is split the data into 4 parts. From here to here is one part, from here to here is the second part, from here to here is the third part, and from here to here is the fourth part. Okay? So the median is of all the data, and then Q1 is basically the median of Q0 and the median, and Q3 is the median of the median and Q4, right? So this is all weird kind of language. So what it's doing is if we had a set of numbers, let's say 9 is going to be the median. So let's fill in maybe 2 other numbers here, 8 and 8 over here, and then we may also have 10 and 11. So let's say this is my set of data, 7, 8, 8, 9, 10, 11, 12. Our min would be 7, the max would be 12, the median's 9 is the central number, right? And then I have 2 numbers on either side of it. So that's what we're getting. We're not adding these up and dividing by the number of numbers or anything like that. We're getting 25% of the distribution of the data, right? If there's 4 parts, 1, 2, 3, 4. Each of those represents 25% of the data. Okay. We also here we have the range. We have something else called the IQR. That's the interquartile range. Okay. The quartile range is inside the box itself. So the interquartile range is basically equal to Q3 minus Q1. Okay, in this case, it's going to be 10 minus 8. And that's equal to 2. So if you notice, the whole range is across the whole box can whisk a plot. Whereas the interquartile range is only the range of the box. All right? And it's basically the inner 50% of the data, if you will. So in this case, it goes from 8 to 10. Right? So if I change to call this one more time, just to look at the data itself, right? 8 to 10 are, whoops, that didn't work. 8 to 10 is going to be these 4 numbers here. All right, that represents 50% of the data, not divided by 2, 50% of the distribution of the data. Okay, which means if we look at 8, it means 25% of the numbers are less than 8 and 25% are greater than 10. All right, and then we can say half. That's what the median represents. 9 is representing the first half of the data, if you will. Right, and that makes sense because we have 4 numbers up to there, and the second half is also 4 numbers. That's why the 9 is in the middle to represent that. Okay, so that's all the numbers we need. And there's one more thing. So since the set of data went from 7 to 12, that's the whisker ends at 7, that's the min, and the other whisker ends at 12. Anything outside of here, I'm just going to put O's for outside, and anything over here outside, they're called outliers. They're not part of the data. Okay. Now there are certain rules where the outlier has to be 1.5 times outside of it, which means, for argument's sake, 99. If somebody was 99 years old, this represents ages. That's definitely an outlier. Where the 13 is too close to the 12, so technically it's an outlier. Not an outlier. The SHSAT normally avoids that kind of a thing. All right. So with all that in mind, this is a 5-minute executive summary of something that would take days and days to learn in your classroom, and lots of discussions and so on. So with that in mind, that is the question. So let's now try to go and look at the number 72 and rip it apart and analyze it. A swim instructor uses the box plot below, that's the one I've been using for my example, to display the distribution of the ages the students are signed up. Now, I gave a certain distribution. They're not saying my numbers are the actual numbers. I only gave them to be demonstrative of what was going on here. All right, so I'm going to scroll past that so we can get the choices showing on the screen, because we don't really need this above. It just says there's a bunch of people swimming. Okay, so it says, what statement about the distribution of ages is true? All right, so it says E, the data contains an outlier, but they're not showing anything outside there. And if they were, it might be a filled in dot like at 6. All right, or they may have gone, in the case of the 99, and said somebody was a 99 over there. So since there's no dots outside of the whiskers, there's no outliers. All right, so the answer to that can't be E. Okay, F, approximately half of the students are exactly 9 years old. Okay, the problem is the median is definitely 9. So let me change the color this one more time so we're clear. Let's do blue. The median here is definitely 9, but this is not the average. So we don't know if it's exactly half. All right, that's the problem with something like that. Okay, the median just means that it has a tendency to be in the middle of the data using this kind of centrality perspective of the data. All right, so median and average are two different ways of getting the center of a data that do not line up to each other. All right, so it says approximately half are 9 years old. Now, even though the median means there's a tendency, it says exactly. What I also don't like, it says approximately exactly. So there's a little conflict there. Anyway, if we look at my set of data, which again was 7, 8, 8, 9, what did I have there? 10, 11, and 12. Okay, half of my data is not 9-year-olds. It just means that's where it leaned in the center. All right, so F doesn't work either. G, approximately 1/4 of the students are at least 10 years old. So here's 10 years old here. And if you listen to what I was saying earlier about quartile, meaning quarter, that's this area right here. So yes, that's about 25%. So about 25% of them are about 10 years old. And even if you look at my data, I have 3 numbers here, right? About out of 1, 2, 3, 4, 5, 6, I have 7 numbers there. So you don't get an exact number, but that's why it says approximately. So that's what it means. That's what a quartile actually means. So G seems to be the answer. And let's just make sure we didn't misread something. It says the interquartile range is 3 greater than the range of the data. Well, we figured out above in the green that the interquartile range was 2. And it says 2 is 3 greater than the range. Well, we said the range was 5. And 2 is not 3 greater than 5. So H is out the window, all right? So that's the analysis we have to do with some of this other kind of stuff. So let me try to find the next question here. I think it was 105. Let me have a paper copy of this just to make sure that I'm following this right. Okay, 105, yes. So 105 is slightly nasty. So let's scroll down to 105. And if you guys are unfamiliar with box plots, you can go to Khan Academy, for instance, and try to figure that out. Okay, so this is what I'm going to do for this question. I'm going to make believe that this line over here is a number line because it's the only kind of legit space I can get out of this. I wouldn't particularly suggest doing this on the real exam because I'm writing on top of question 106 and I haven't answered it yet. But I'm just going to use this for demonstrative purposes. So it says the manager of a shipping company records the weights and pounds of the last 9 packages of a shipping company. The manager displays the distribution, right? Because that's what a box plot's showing us, the distribution of the weights in the box plot with the 5-number summary below. So they're going to give us the min, the max, all this other stuff. So I'm gonna set that up here. So this is going to be my min. My max I'm going to put over here. All right, so it's telling me, and I'm going to check them off as I do them. My minimum is 29. Okay, my max is over here. That's 98. Okay, and obviously this will be a number line extending out that way, and this will be the number line extending out that way as well, okay? It says the median is 42. So it seems to me there's about 70 numbers in here. So the median being 42 means it's about 12 away. So I'm just going to rando say 42 is here. Okay, it may not be to scale. So 42 is here. All right, so that's the median. Okay, and then it's going to give us the first quartile and the third quartile. That's going to be the dimensions of the box. Okay, so it's starting at 31, which is pretty close to the min. Okay, and then it's going to go to 73. So I'm going to say 73 is about right here. So what I'm going to do is draw my box there. Whoops. It should adjust to that. No, it didn't. Okay, wait. Let's do that over. So my box is here. So this means this is my Q1. Okay, and they're telling us that's 31. Okay, and my Q3, that's going to be the third quartile. So that's 73. So it said there were 9 packages. They don't give us the package weights, but this is the distribution of that data. All right, so at this point, we've represented what the thing actually is and not is. All right. So it says, which statement about the distribution of the weights is supported by the box plot the manager created? It says the minimum 29, so that's our point right here, is an outlier. Well, an outlier is outside of it. So even though min is the least number, it's not outside the whiskers. So it's not an outlier. It's an inlier. Okay. 98, the maximum, has the same thing. It's actually on the whiskers, so it's not beyond it. So it's an inlier. It's not an outlier. Okay. And then it says the interquartile range of the data is 11. So what we need to do is the IQR, if you remember from the other example, was Q3 minus Q1. So in this case, that's going to be equal to 73 minus 31. Okay, and that is equal to 42. All right, so it is not 11. So that means the answer has to be D, but let's prove it. It says the interquartile range, which we just computed, was 42, and the median, which is 42, is equal. All right, so that gives us D. That actually jives, so that means D is the right answer. That is the analysis you have to give some of this. So these are tedious. They're not always 5-second questions. I think the next one, which is 108, where do I have 108? Yeah, that one isn't too bad. And it's a subtle box plot question, but it's simple. And now with everything we know about the box plots, we should be able to do it. So again, we look at the illustration first. The min is 7, the max is 18, the median is 10, Q1 is 8, and Q3 is 17. So we don't know what the data is about. It's all single and double digits. Could be ages again, so let's read it and figure it out now that we have some sense of the magnitude that's going on here in the data. Okay. At a carnival, visitors can win a prize if an employee can correctly guess their age. The employee records the first 15 ages he guesses one Saturday. The box plot shown shows the ages he recorded. So that's the distribution of ages. So the youngest person was 7. The oldest person was 17, and the way it went back and forth. So it seems like there was a lot of people who were teenagers, because that makes that there. And then there was a bunch of people, maybe 9-year-olds as well. All right. So on the one hand, we got a distribution across different ones. On the other hand, we probably got a lot of ages around 9 as well. That's the balance. That's how 10 ends up being the middle number. Right? So we may have gotten 10, 11, 12, 13, 14, 15, and 16, but a whole bunch of 9s were there as well. So it counteracts that and that's why 10 can be the median. So it says, what's the interquartile range? Well, again, we just did that twice. So the IQR is equal to Q3 minus Q1. Q3 is that's the 17, and Q1 is the 8. All right, so when we subtract 2 of those, we get 9. That's all they're asking us to do on that question. All right. Okay, so what I'm going to do is do a second video with the Form B. This was from Form A, and then we'll resync on that side. All right, y'all. Peace.